Okay, so we have a question about an inequality and also quadratic function, addition of mathematics. Okay, so part 1 says find the range of values of x for which x open bracket 9 minus x is greater than or equal to 18. Okay, so how do you answer such questions? So when you have x and then 9 minus x greater than or equal to 18, I want you to find the values of x that are going to satisfy that inequality. So how do we go about it? So the steps are very simple. Just solve it as an inequality. So I like solving it in a form where we have a 0 on the right hand side. So let's expand x by 9, 9x, x times negative x is negative x squared greater than or equal to 18. We can subtract 18 from both sides so that you can eliminate it on the right. So we have 9x minus x squared minus 18 greater than or equal to 0. Okay, so at this point let's write it in the form of a quadratic. So we have negative x squared plus 9x minus 18. I've just changed the order of writing by starting with the 1 with the power x squared and then the 9 and then the negative 18. Okay, so the easiest way of dealing with such questions where you're dealing with inequalities, I would recommend each time you go by factorization. It's a faster and the easier way of going about it. So let's try to do that. So how do we easily factorize? So look at the coefficient of x squared every time, and then look at the constant c. We know a quadratic function is in the form of ax squared plus bx plus c. So the product is a multiplied by c. A is a coefficient of x squared. In this case, it is negative 1. So therefore, product is negative 1 times negative 18, which is a constant. That gives us positive 18. The sum is always the middle part, which is 9. Factors, these should be the numbers that if you multiply they give you 18, you add them they give you 9. So what are these two numbers? So that is 6 and 3. 6 times 3 is 18. 6 plus 3 is 9. That's why we call this the product and that the sum. Okay, so let's now try to factorize. So how do we go about it? So let me remove this part. So what happens is when you've determined the factors come to represent the sum. So we have negative x squared. Where there is a sum, we're going to put 6x plus 3x, which of course if you add they'll give you 9x minus 18 greater than or equal to 0. Okay, we can now move. So we can group the two parts, separate them and then factorize. So for the first one, I'll factor out negative x and then remain with x minus 6, and then for the other part we can factor out a 3, which will give us x and then minus 6. So what is in the brackets should always match. So the basic idea is if you multiply this with whatever is inside, it takes you back to the previous step, right? That's the point of factorization. So we can now group this with that. So that would be negative x plus 3, and then also just get one bracket, which is x minus 6. So at this point we've factorized our inequality. How do we now answer it? We're trying to determine the values of x that are going to satisfy that inequality. Okay, so let's draw a number line. Just draw a number line. I can remove that part. Let me draw a number line somewhere on top. Okay, so we have a number line, and then so let's try to find the values of x. Let's take it as though it's an equation. The ones that are going to satisfy the fact that it's 0, right? The zeros of this inequality. So equate all these to 0. So negative x plus 3 is equal to 0. Negative x becomes negative 3. So x is equal to 3. For the other bracket, x will be equal to 6. So we have 3 and 6. So the way we go about this is we have to try the left, the middle part, and the right. Okay, so let's try the middle part. Any number between 3 and 6 that you can think of. You can think of a 4. You can get any number, literally any number, even 5 if you want, or even any decimal number, but I prefer going for the bigger ones. So 4. So we'll try out in this factorized form so that we solve it faster. So what happens if we put a 4 where we have x? In the first bracket, negative 4 plus 3 gives us negative 1. In the other bracket, we get negative 2. So negative times negative, we'll get a positive 2. Okay. Now the question that you're going to ask yourself is positive 2 greater than or equal to 0? Is positive 2 greater than or equal to 0? Yes, it is. So in other terms, you don't even have to find the actual values. You can just go by the signs. Negative 4 plus 3, you've got a bigger negative number, so you get a negative from that bracket. 4 minus 6, you get a negative. So negative times negative is positive. So positive is greater than 0, right? So this is satisfying the inequality from the number line that we have. Okay. So before we conclude completely, let's try out the other parts. So I can try the left and the right hand side. Numbers that are greater than 6. I can try a 7. So if I put a 7 where we have our x, what basically happens if I put a 7 there? 7, 7. So negative 7 plus 3, that will give me a negative. 7 minus 6 will be a positive 1. So negative times positive is negative. So a negative number is it greater than 0? No, it's not. So that part has refused in this case. Obviously, if you try the other part, you expect it also refuse. Let's try. So let's try. I'll prefer even to go for a 0 since 0 is less than 3. So if we put a 0, it means we're only remaining with a 3 itself and negative 6. So we have a positive and a negative, which is still a negative. So a negative is less than 0, meaning that in this case it doesn't satisfy the inequality because it says greater than or equal to 0. So therefore, the answer is the middle part, 3, between 3 and 6. So how do we present that answer? So we'll say 3 is less than or equal to x, and then x is less than or equal to 6. Okay. So if you try these numbers between 3 and 6, including 3 and 6 themselves, you're either going to get a 0 or you get a value greater than 0. So that's the range of values of x that will be able to satisfy that inequality. Okay, let's look at B now. B is asking us to express this quadratic function in the form of that. So the way you go about this question is, in short, you're just computing the square. That's all we're doing, just computing the square. That's what we're trying to do. We're computing the square. Okay. So how do you go about it? So let me show you first of all you compute the square, and then I'll show you the other way of approaching the same question. Okay, so the first way you can approach it, that is by computing the square. You have negative 2x squared minus 5x plus 7 equal to 0. So when you're computing the square, you need to ensure that first of all the coefficient of x squared should be just a 1 and a positive 1, that is. So in this case, I need to factor out the 2. Let me factorize the 2. So I remain with just a positive x squared, and then in the middle part, so in short, in other terms, we're dividing throughout by negative 2. So for the middle part, we're going to have 5 over 2x, and then plus 7. 7 will become negative, since we're dividing by negative 2, equal to 0. So the idea is, when you're dealing with this, the idea or the concept here is, if you multiply the negative 2, whatever is inside, it should take you back to the previous step. Okay, so I'll forget about the brackets and the negative 2 for now, and just try to answer what is inside. So we have x squared plus 5 over 2x. So I can take the constant the other side, so it becomes 7 over 2, positive 7 over 2. So when you're computing the square, you need to ask yourself a question. what is the half of the coefficient of 5 over 2? So in short, you're dividing 5 over 2 by 2. Or in other terms, you're multiplying by half. So you get 5 over 4 after dividing by 2. So add that on the left and the right. That's what it means to complete the square. So we'll say plus 5 over 4, the square of it. We do that to the right as well. Okay. So after this point, what happens is you need to group the squares. So x and this part, the px, this part will disappear. So we have x grouped with 5 over 4 the power 2 equal to 7 over 2. 5 over 4 squared is 25 over 16. So we've computed the square. We just need to simplify, then we are done. So we just have like fractions there. 7 over 2 plus 25 over 16. Common denominator 16. 2 into 16 is 8. 8 times 7 is 56. 56 plus 25, 81. So we have on the right, we'll end up with 81 over 16. So we can have this go to the left hand side. So what are we going to end up with? We end up with a negative part, right? So it will become negative 81 over 16 equal to 0. Are we in that form already? No, not yet. So don't forget that we put out a negative 2 there, so we can bring it back. Negative 2. Now the idea of the question is they want us only to have a coefficient outside the brackets of what is squared, and then we need to have a constant c separate. So that step now will force us to distribute the negative 2. So we have negative 2, and then x plus 5 over 4, the power 2. And then this negative 2 has to be multiplied by the constant. Okay? So obviously, you can just easily divide the 2 into the 16, so that gives you 8, right? So we have positive 81 over 8 equal to 0. So if you now check that, that is already in that form, right? It has now come out in the form of ax squared plus b plus c. Now, here is a tip. Here is a trick that I like using when it comes to issues to go about this, like how a trick that I use when I want to like confirm if I'm right with my solution. So for the other part which says find the coordinates of a turning point, for a turning point I know the formula is negative b over 2f for the value of x. So if I try to substitute, our b is negative 5, our a is negative 2. So I have 5 over 4. So on top you have a positive, so you end up with a negative. So negative 5 over 4. So you find the turning point. The value of x is, you get that x plus 5 over 4, whatever is in the brackets, and equate to 0. So what you find is the x coordinate for the turning point. Now the question would be, how do you find what? The turning point in terms of that form. How do you know which one is the turning point? So this c is the y coordinate. So it's negative 5 over 4, comma, 81 over 8. We can actually prove that by trying to substitute the value of x into the original equation there. Yeah. So that's how you can answer it using the computing the square method. Now you can also approach it by another method that I would also like to show you in this tutorial. Another way is if you're not so sure about or you're not comfortable with computing the square, which I feel is also very simple, just expand that. So how do you expand it? So you can have a brackets, expand that, so x plus b multiplied by x plus b plus c. So if you do actually expand it, you're going to have a multiplied by x times x is x squared So it will be 2bx plus b squared, okay, plus c. You can distribute the a, so you have ax squared plus 2abx plus ab squared plus c. So you can just equate this now to 7. Let me write it in the form of, so negative 2x squared minus 5x plus 7, and then you can come up with equations that relate the two. So how? So for the ax squared, you only have that part, so x squared can cancel out, so a is equal to negative 2, so find the value of a, and then look at this part, 2abx, that part we only have negative 5x, so we have 2ab being equal to negative 5. Your a is already found to be negative 2, so you can distribute, so you're going to get negative 4, so you end up with negative 4, b is equal to negative 5, so b becomes 5 over 4. So I've seen that the RVs are already confirming what we have. So now you can finally find your c by getting this last part, ab squared, the constant we have. So a b squared plus c should be equal to the constant 7. Now don't forget that the value of a has already been found to be negative 2. The value of b has been found to be 5 over 4. So 5 over 4 squared plus c is equal to 7. So you're going to have negative 2 multiplied by 25 over 16, which is going to give us plus c is equal to 7. This is 1, there it's 8. So we have negative 25. Negative 25 over 8 plus c is equal to 7. You can have it go the other side, so I have plus 25 over 8. Now 25 over 8 plus a 7. So your c just basically becomes 8 times 7 is 56. So 56 plus 25 is 81, so you have 81 over 8. So you found all the values of a, b, and c. You can just now substitute. So your a is negative 2, your b is 5 over 4, and then your c is 81 over 8. So that's another way you can handle this question.